You guys have logged into the session. Give me a minute while I check if technically everything is fine. Okay, everything looks fine. Yeah. All right, so let's begin, guys. I don't see any active audience yet, but they're going to join during the course of this session. All right, so welcome everyone to this session where we're going to discuss base systems as a concept under number systems. It's quite intimidating for a lot of people, but it's very easy if you understand the basics of this particular concept. Okay, this is a live class taken by me, Bhavuk Pujara, on YouTube for Unacademy. A little bit about me, you can visit this link, unacademy.com/user/Bhavuk Pujara, to know more about me. Okay, this live class expectation is that base systems is one intimidating chapter to many. In this class, we discuss basic concepts of this concept, basic concepts of base systems as a chapter, plus some observations, plus some practice questions, and some previous year's questions. For detailed understanding of such topics, I would recommend that you check out Unacademy Plus. You get access to more practice questions solved live in the session, more similar intimidating topics discussed in live classes, live doubt clearing sessions like live revision sessions, weekly sectional tests, and finally mock tests. And also above and beyond all this, you get to interact with us live. Right? You can ask your doubts, you can provide your suggestions in a way that if you want us to take a particular session on a particular topic or particular group of topics that you're weak in, we educators here consider your request and we post live classes like that. We create courses out of that too. Okay, with Unacademy Plus, you get all live and structured courses, access to all live and structured courses, lessons by all us top educators on the platform, and weekly quizzes and doubt clearing sessions. These are how the commercials look like of Unacademy Plus. If you buy it just for 1 month, you can try and test waters by, say, taking a 7 months trial, right? After that, it's going to cost you 3,500 rupees per month if you take for 1 month. If you take for 3 months, it will cost you 2,917 rupees per month. If you take for 6 months, it's going to be 2,333 rupees per month. This is something we recommend to 2019 aspirants, that is class of 2020 to 2022 MBA batch. And someone who's preparing for CAT 2020 and OMETS 2020, I would say check out this 12 months subscription where the cost is going to come down to 1,458 rupees per month for 12 months. And above and beyond this, you'll get additional discounts if you use this code, which is Bhavuk Pujara. That is my profile name on the platform Unacademy. Okay. Charlie, let's begin. Base systems. The most common kind of base system, type of base system, is the decimal base system in which we count today, in which we do mathematical operations today. So, the number of digits or the kind of digits that we use in decimal base system are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are single digit numbers that we use. 0 through 9 are the digits that we use. This is base 10. The base 10 means there will be 10 digits I'll be using to create a number, to form any number. Any 1, 2, 3 or any, I would say n number of digits out of these 10 digits can be used. A lot of combinations can be done to form any number. Binary means base 2. That means you'll be using only 2 digits to form a number, 0 or 1. Or these 2 digits can be used in a way that a 5-digit number can be formed, which can be 1, 0, 1, 0, 1, then 1, 0, 0, 1, 0, and so on. Digits cannot be beyond 0 and 1. They cannot be anything different. Octal, that is base 8. That means 8 digits will be used from 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Hexadecimal is base 16. 16 digits will be used. Now what are these 16 digits? Because in our mathematics, we have only learned 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now after this, we have A, B, C, D, E and F. A represents number 10, B represents number 11, and so on up till F that represents number 15 in base 16, that is hexadecimal base system. So these are common types of base systems that we're looking at on the screen. Okay, the first application is that you're asked to convert any base to decimal. So any base, say in base 3 a number is given to you, or in base 8 a number is given to you, or base 5 a number is given to you, you have to convert this number into decimal base. What this number will appear in base 10 is what the question appears to be. Okay. How do you do that? For example, the question is 243 in base 8 has to be converted to base 10. How would you do that? You would do this application. What is the source base? 8. What is the destination base? 10. So what you're going to do is, you're going to take this source base 8, raise it with 0, multiply it with the units digit, plus take the source base 8, raise it with 1, multiply it with the 10th digit, which is 4, plus you take the source base, which is 8, raise it with the power 2, multiply it with the 100th digit, and so on. If there were more such digits, you would do plus 8 cube into 1000th digit number, plus 8 raised to the power 4 into 10,000 digit number, and so on. What you're eventually doing is doing 8 raised to the power 0, leaving some space, plus 8 raised to the power 1, leaving some space, plus 8 raised to the power 2, and so on. Okay? You'll take the units digit, put it here, 10th digit, put it here, 100th digit, put it here. Okay? Let me check on my other device if you have any doubts or any questions raised by anyone live in the session. Okay, nothing yet. So far so good. So this is what we do. So 8 raised to the power 0 into 3 is 1 into 3, that is 3. Plus 8 raised to the power 1 into 4 is 32. Plus 8 squared into 2 is 128. This gives you 163 as the answer. What is 163? This is the answer in base 10. So 243 in base 8 will be 163 in base 10. Now one thing to note, one observation, is that if you're converting from a lower base to a higher base, right, in this case we were converting from lower base, that is 8, to a higher base, that is 10, right? So the absolute value, the value that we are converting, is going to decrease. If the base value is increasing, the absolute value is going to increase, and vice versa. If the base value was decreasing, the absolute value will increase. Higher base, lower absolute value. Lower base, higher absolute value. Okay? Let's do some examples. 143 in base 5 has to be converted to base 10. How would we do that? Lower base to higher base. Therefore, the value that I am finding out has to be less than 143, because the absolute value will be lower. You're converting from lower base to higher base, absolute value will be higher to lower. It will be 5 raised to the power 0, leave some space, plus 5 raised to the power 1, leave some space, plus 5 raised to the power 2, leave some space. 5 raised to the power 0 multiplied by units digit, plus 5 raised to the power 1 multiplied by tens digit, plus 5 square multiplied by hundredths digit. It becomes 3 plus 20 plus 25. That becomes 48. So the value of 143 in base 5 is going to be 48 in base 10. Okay? Another example. 143 in base 6 has to be converted to base 10. How do we do this? Take, what is the source base? 6. So 6 raised to the power 0, leave some space, plus 6 raised to the power 1, leave some space, plus 6 raised to the power 2, leave some space. 6 raised to the power 0 will be multiplied with the units digit, which is 3. 6 raised to the power 1 will be multiplied with the 10th digit, which is 4. 6 raised to the power 2 will be multiplied with the 100th digit, which is 1. Therefore, my answer is going to be 1 into 3 plus 6 into 4 is 24 plus 6 squared into 1, which is 36. The answer is total 63 in base 10. Okay. Next example, 143 in base 9 has to be converted to base 10. Same concept, 9 is for 0, leave some space, plus 9 is for 1, leave some space, plus 9 square, leave some space. 9 is for 0 will be multiplied with the units digit, plus 9 is for 1 will be multiplied with the tens digit, plus 9 square will be multiplied with the hundredths digit. It becomes 3 plus 36 plus 81, which becomes 120 as the answer. So 143 in base 9 will be 120 in base 10. The base value is increasing from 9 to 10. The absolute value will decrease from 143 to 120. Okay. Next concept is converting from decimal to any base. So we just learned how to convert from any base to decimal. Now we're going to learn to convert from decimal to any base. Okay. Now let's see. For example, you have to convert a number in decimal to base 5 or base 2 or base 6. There's a number given to you 347 in base 10. It has to be converted to base 6. What you do is take this number 347 divided by 6. What is the remainder? 5. Because 6 into 57 is 342. Remainder is 5. Quotient is written here. Now, is this number less than 6? No. So we do perform this activity again. It has to be less than 6. 6 9s are 54. What is the remainder? 3. Quotient 9. Is this number less than 6? No. So we do it again. 6 1s are 6. The remainder is 3. Quotient is 1. What you do is form a number from this last quotient and go up to the first remainder. The number formed is 1 3 3 5. So 347 in base 10 is 1335 in base 6. Okay. Some important points here. Form a number from remainder starting from last through first. That is what we did. 1, 3, 3 and 5. The number is formed. Now, when converting a number from base x to decimal, answer is such that when divided by x, remainder equals units digit of number in base x. Now check this out, this result. A very important observation. When you are dividing 347 by 6, the first remainder that you get is also the units digit of this converted number. Right? This is what this result is all about. Let's do another example. 146 base 8 has to be converted to decimal. How would you do that? 8 is for 0 into 6, the units digit, plus 8 is for 1 into hundredths digit, which is 4, plus 8 square into the hundredths digit. 8 is for 1 will be into tenths digit, plus 8 square into the hundredths digit, which is 1. Answer is 6 plus 32 plus 64, which is 102. Now 102 when divided by 8 gives a quotient as 12, remainder as 6. 6 is also the units digit of this number in base 8. How interesting is that? Let's do some more examples. Find the value of 342 in base 10 in base 4. So you're given 342 base 10. You have to find out this value in base 4. How will you do that? Simple formula, simple method we discussed. Decimal to any base. Okay, take that base value. Divide this value 342 by that base value, which is 4. So 342 divided by 4 gives you the quotient as 85, remainder as 2. 85 divided by 4, quotient as 21, remainder as 1. 21 divided by 4, quotient as 5, remainder as 1. 5 divided by 4, quotient as 1, remainder as 1. Form the number from the last quotient value up through the remainder, the first remainder. The number thus formed is 4 times 1, 2. Therefore, 342 in base 10 when converted to base 4 gives me the value 11112. Okay. Let's do another example. 342 base 10 has to be converted to base 8. Divide 342 by 8. What is the question? 42. What is the remainder? 6. 42 has to be divided by 8 again. What is the question? 5. What is the remainder? 2. The number formed will be 526 in base 8. Therefore, 342 in base 10 is equivalent to 526 in base 8. So I'm going to keep the session open for a minute. If people who are watching this live have any doubts. Okay, I don't see any comments. I'm checking my device. Alright. Probably people are going to watch this as a recorded session. Okay, let's move ahead then. I'm going to solve some practice questions, do some practice questions here. Some questions that have appeared in previous year's exams. Exam that you're preparing for. Example number 1, question number 1. You're given an expression x, x and x in base b is equal to x raised to power 3, where b is base, x is any digit in base b. You have to find the value of b. Options are 5, 6, 7, 9 or none of the above. It's a ZAT 2013 question and we'll see how could we find out the answer to this question. Okay, what we do is convert this triple x in base b to decimal. How do we do that? It will be b raised to power 0 into x plus b raised to power 1 into x plus b square into x is equal to x cubed. This becomes b square plus b plus 1 is equal to x square. Now x has to be greater than or equal to b because x is a digit in base b. Now it has to be less than b. X is any digit in b. Okay, this has to be less than b, right? So in this case, from this equation we find out that x squared is equal to b squared plus b plus 1. Okay, therefore x turns out to be greater than or equal to b because b squared plus b plus 1 is equal to x squared. So x has to be the value has to be in a way that it exceeds b square q value. X square q value exceeds b square q value because b square may b add over 1 be add over and then we are coming up to x square, right? But we know that x is a digit in base b, therefore it cannot be greater than or equal to the base value b. What we mean here is that if we take base 2 for example, the digits in base 2 can only be 0 and 1. If we take base 5 for example, the digits in base 5 can only be 0, 1, 2, 3, 4. So the digits that we are using in any base system, those digits values have to be less than the base value. Okay, so x by the nature of base systems has to be less than b. Therefore, it cannot be greater than or equal to base value b. That is getting implied from this equation. Therefore, x has to be less than b, which is the property of bases and the digits. Therefore, b cannot assume any value. Therefore, the value of b will be none of the above. A simple question. Okay, and this question appeared in CAT 2013. Very simple question. Could be solved in less than 30 seconds if we came up this equation. Okay, simple question based on number systems, base systems that appeared in CAT 2013. Let's move on to the next such question. This question appeared in CAT 2003. Okay, if there's anyone, I see there's some active audience who joined the session. If you guys have any doubts, please let me know. Okay, no doubts. Let's begin solving this question. A positive whole number m less than 100 is represented in base 2, base 3 and base 5. If it is found that in all the three cases, last digit is 1, sorry, while in exactly two of the three cases, leading digit is 1, then m equals, you have to find out. Options are 31, 63, 75 and 91. A positive whole number m less than 100 is represented in base 2, base 3 and base 5. It is found that in all the three cases, last digit is 1, while in exactly two of the three cases, leading digit is 1. We would find out the value of m. This question has to be solved using options. Simple question based on base systems. Recall the concept of remainders of numbers in other bases. This is something we just discussed some time back. When converted from decimal to another base, say x, the last digit of this number in base x is also the remainder when this number is divided by x. For example, let's take this example. Okay, 342 in decimal has to be converted to base 4. The number is 11112. So what this question is saying that remainder when 342 is divided by 4 is the same as the last digit of this converted number in base 4, which is 2 only. Okay? This is what the concept, what we're going to use here. Now in all the cases, the last digit is 1. It is given in the question. After the conversion, in all the three cases, last digit is 1. Okay? Chaliye. Therefore, the number should give the remainder as 1 when divided by 2, 3 and 5 individually. 31 when divided by 2 gives me the remainder 1, okay. When divided by 3 gives me the remainder 1, okay. Divided by 5 gives me the remainder 1, okay. So this is a probable answer. 63 when divided by 2 gives me the remainder 1, okay. But by 3 gives me the remainder 0. Therefore, this is not my probable answer. 75 divided by 3 will give me a remainder 0. Again, not a probable answer. 91 when divided by 2, 3 and 5 individually will give me a remainder, again 1. Therefore, 31 and 91 are the two numbers that we are talking about here. Answer is either of the two, 31 or 91. Now it is given that the leading digit in exactly two of the three cases is 1. When I convert number 31 in base 2, and base 3 and base 5, it gives me the leading digit as 1 all the time. But in 91, When I convert 91 into base 2, base 3 and base 5, it gives me the leading digit as 1 in only 2 cases. Okay? In base 2 and base 3, 91 gives me the leading digit as 1, but in base 5, my leading digit is 3 of the number 91 in decimal when converted to base 5. Therefore, in 2 out of 3 cases, the number 91 when converted to base 2, 3 and 5, in 2 out of these 3 cases, the leading digit is 1. And in all the 3 cases, my trailing digit, or the last digit, is 1. Therefore, my answer is going to be option D, which is 91. This has been a CAT 2003 question. Okay. Again, I'm going to leave the session open for a minute if anyone has any doubts. Okay, no doubts coming in. Let's continue then. All right. Let's solve this next question. What is the greatest 4-digit perfect square in base 7? This question has appeared in CAT 1998. It's a very interesting question though. Although very old, it's a very interesting question. What is the greatest 4-digit perfect square in base 7? How will you solve this question? How will you think around this question? Recall that in decimal system, that is base 10, greatest 4-digit number is formed by squaring greatest 2-digit number, that is 99. When squared gives me 9801. I couldn't have taken 100, which is the smallest 3-digit number, because on squaring it will give me a 5-digit number, that is 10,000. I have to find out the greatest 4-digit number, which is a perfect square, can only be found out by squaring greatest 2-digit number, which is 99. Okay. Likewise, the greatest 4-digit number in base 7 will be formed by squaring greatest 2-digit number in base 7. Now the greatest 2-digit number in base 7 is 66. Right? When I square 66 in base 7, so 66 into 66 cannot be done in decimal. So do not do this multiplication in decimal. You have to convert it to decimal, square it and convert it back to base 7. Okay, so that is going to be my answer. We also know how to multiply and add in other bases. That is something we're going to discuss some other time. We don't have any active audience, so I don't want to get into this complex discussion. If anyone has any doubts, please post to me or please get back to me by messaging me on the platform if they want to understand how to multiply and add in other bases. Right, that is something I usually take when we have some active audience so that they can post their doubts parallelly, because it's not very easy to explain this. Okay, so the answer turns out to be 6501 in base 7. Therefore, the greatest 4-digit perfect square in base 7 is 6501. Interesting. Another question. In a number system, product of, or in a base system, not number system, in a base system, product of 44 and 11 is 1034. Number 3111 in the system when converted to decimal will be equal to something you need to find out now. Answers, options are 406, 1086, 213 or 691. It's a CAT 2001 question. First thought, it's a question on base systems. Second thought, mathematical operations in other base systems. You have to recall how to multiply in other base systems. Let's quickly go through it. It is given that 44 into 11 in other base, we don't know what the base is. It's giving me 1034. First of all, let's try to understand what all possible bases are we're talking about here. So the base here cannot be, first of all, 1, 2, 3 or 4, because the highest digit that I see is 4. And digit 4 does not exist in its own base 4. Okay? So the lowest base that I'm talking about is either base 5, base 6, 7, 8, 9, 10, not 10, because 44 into 11 will give you 484, which is not happening here. So base 10 is not the base that we're talking about. And even beyond that. Now, one thing to note is that when I multiplied 44 and 11 in decimal base, I got 484. But the answer here is 1034. So the absolute value is decreasing on converting. Therefore, the base value will decrease on converting. Okay. So my value, base value has to be less than 10 and greater than 4. My options are 5, 6, 7, 8 and 9. The 5 options that I've left with. So I multiply 44 and 11. I start with base 5. When I do this, I get 1034. So for this, you need to understand how to multiply in other bases. In this case, base 5. You can watch out my lessons. You can watch my lessons on base systems uploaded on Unacademy. And I've also taken some special classes where I've discussed this. So try to solve it yourself. If you have any doubts, you can get back to me. Okay. So I found out that when multiplied in other base, 44 and 11, give me the answer 1034. This was in the case of base 5. Okay. And that is what the question is also saying. Therefore, now I know what base system we are talking about, which is base 5. Now, 3111 in base 5 has to be converted to decimal base. Simple conversion. Write down 5 raised to the power 0, leave some space, plus 5 raised to the power 1, leave some space, plus 5 square, leave some space, plus 5 cube, leave some space. So it will be 5 raised to the power 0 into 1, plus 5 raised to the power 1 into 1, plus 5 square into 1, plus 5 cube into 3. My answer is going to be 375 plus 25 plus 5 plus 1, which is 406. So from the options, I saw that the answer is 406. Okay. This was CAT 2001 question. Another question, let's take. A number represented as x362 in the decimal system, where x is a single digit number, is divisible by 9. x362 is simple base 10, that is something we use today, right? X is a single digit number, and this number x362 is a multiple of 9. Okay? We have to find out x362 can be represented in octal system as, it's a theta question. You have to find out when this number is converted to octal system, that is base 8, what is my answer going to be? Now we know that x362 in decimal system is divisible by 9. Therefore, x plus 3 plus 6 plus 2 is a multiple of 9. That is what the divisibility of 9 rule says. If a number is divisible by 9, that means the sum of the digits of that number is also divisible by 9. So x plus 3 plus 6 plus 2 gives me what? X plus 11 has to be a multiple of 9. X plus 11, if you see, and x is a single digit number, x has to be 7. Therefore, the value of x here is 7. Therefore, the number becomes 7362 in decimal system. Okay? All you have to do is convert 7362 from base 10 to base 8. How will you convert it? Divide 7362 by 8. Write down the quotient. Write down the remainder. If that quotient is greater than 8, divide it again. Write down the quotient and remainder. This is something we have done in the earlier part of this class. Please go through that. How to convert from base 10 to base 8. I'll be back in a minute. There's someone at the door, guys. Give me a minute. I'll be back. Okay, when I convert 7362 from base 10 to base 8, I get the answer as 16302. Okay, another solved example on base systems. Let's do another question. 10 is to the 67 minus 87 is written as an integer in base 10 notation. What is the sum of digits in that integer? In that base system. Or sum of digits in that integer only. Okay. So 10 is to the 67 minus 87 is written as an integer in base 10 notation. What is the sum of digits in that integer? Let's see. We know 10 is to the 67 has 1, 1 and 67 zeros. Something like this. Zeros are 67 times. Now we have to subtract 87 from this. We get total 67 digits, out of which 65 digits will be all 9s and last 2 digits will be 1, 3. Right? For example, 100 minus 87. What does it give you? 13. This is what the last 2 digit is going to be. Rest are going to be all 9s. Now you have 65 9s and 1, 1 and 1, 3. Add them all, you get 9 into 65 plus 1 plus 3, which is 589. Therefore, this is the question, which is 10 to the 67 minus 87 written as an integer base 10 notation. The sum of the digits is going to be, of this number, is going to be 589. Pretty simple. Okay, with this we come to the end of the session. I'm going to leave the session open for next 10 minutes. If you guys have any doubts, any questions, and anyone who's attending this session as a live audience can get back to me with any doubts. Okay, so we discussed some common base systems: decimal, binary, octal, hexadecimal. Base 16 is hexadecimal, octal is base 8, binary is base 2, decimal is base 10. Right? Then we learned to convert value from any base to decimal. Say from base 3 or base 8 or base 5, you had to convert to base 10. What will you do? You do 8 raised to the 0, for example. 243 in base 8 has to be converted to decimal. You'll do 8 raised to the 0 into the units digit plus 8 raised to the 1 into the 10th digit plus 8 square into the 100th digit plus 8 cube into the 1000th digit if we had any, and so on. If you're converting from a lower base to a higher base, the absolute value is going to be higher to lower. So base value is lower to higher, absolute value will be higher to lower, and vice versa. Okay, we did some examples. Then how to convert from decimal to any base. Take the value, for example, 347 base 10 had to be converted to base 6. How will you do that? We'll divide 347 by 6. You write on the quotient here and the remainder here. 57 is the first quotient. Is it less than 6? No. So you'll have to perform this activity again. 57 divided by 6. Quotient is 9. 654. Remainder is 3. Is 9 less than 6? No. So you'll have to do it again. 9 divided by 6. Quotient is 1. Remainder is 3. Number formed from the last quotient up through the first remainder. That is 1, 3, 3 and 5. This is the number that is formed. Will be my answer here in this base. So 347 base 10 will be 1335 in base 6. We did some examples. Converting 342 in base 10 to base 4. 342 in base 10 to base 8 and so on. We'll solve some questions. Okay. So people, if they have any doubts, please let me know. I'll be back in a minute. Alright, I don't see any comments, any questions coming in. So we solved some examples based on base systems. Solved 6 questions here. Questions that have appeared in XAT and CAT. One question was from XAT 2013, then from CAT 2003, then from CAT 1998, then from CAT 2001, and some more examples. Okay, so we're going to connect again tomorrow, where we will discuss some more important topics, say coordinate geometry, some number systems continuation for IIFT 2019. Okay, people who are watching this as a recording can connect again tomorrow if they have any doubts based on this particular video or based on any concept that we have discussed so far on YouTube. Can please get back to me with their questions and doubts. I'll be happy to help in any way I can. Okay, so let's close the session now. If there are no doubts coming in, let's keep the session open for another couple of minutes if someone joins in. All right, let's close the session now. Thank you so much for joining. Thank you so much for watching as a recording. If you're watching as a non-active, non-live audience, we'll connect again sometime soon. Goodbye, guys.